Okay, this is the start of Unit 8, last unit, trigonometry. This first section is all about the vocabulary words that you'll be using in this unit, such as quadrantal, reference angles, coterminal angles, things like that. So, first, back when you guys learned quadrants, okay, you've been doing this for a couple years, did geometry, algebra 2, but they named the quadrants, and with using Roman numerals, this is always quadrant 1. This is always quadrant 2. It goes counterclockwise because that's the way positive angles go. Quadrant 3 and quadrant 4. So know your quadrants. Then, because the quadrants go counterclockwise, positive angles are always counterclockwise. For example, let's draw a 170 degree angle. If I said draw a 170 degree angle, first you start on this positive x-axis. It's called the initial side. And you use a rotating arrow like this. This is 90 right there. 180 is all a straight angle. So you want to stop about 10 degrees shy of this angle. And then you would draw a terminal ray. And that's how you would draw a 170 degree angle. With the initial side, a rotating arrow, and something called a terminal side. But notice we went counterclockwise 170 degrees. The negative angles, they're the ones that go clockwise. Negative angles, they go clockwise. So if I said draw negative 60, again, you always start on this positive x-axis. That's the initial side. Using your rotating arrow, go about 60 degrees. It's about right there. Draw a terminal ray like that, and that's negative 60 degrees. So we went clockwise. Negatives go clockwise. So the initial side is always along the positive x-axis, and that means, so if I ever say draw the angle in standard position, you start on the positive x-axis. Degrees, minutes, and seconds. This isn't that big of a deal unless you're going to be working in a submarine in the Navy, or if you're going to be an air traffic controller, or someone that is an engineer where angles have to be exact and not rounded. So when it says 34.95, this might be a rounded decimal. Well, there's another way that you can write this, 34 degrees and something minutes. So there's a key on your calculator. Let me clear this. See this apps key right here? See the apps key? Right above it is the word angle. Do you see the word angle in blue? So to get that word, you have to press second apps. So we're going to do that right now. You're going to press, first of all, it says right here what to do. Enter the angle measure, go to second angle, choose DMS. So it says what to do right here in the box. So that means you want to type in the angle, 34.95. See how I typed in the angle? Now you're going to press second apps, which we really want the angle word above it. So press second apps. Now, when you do that, you get this screen here. We want number 4, DMS. It's degrees, minutes, seconds. Degrees, minutes, seconds, DMS. So you're going to press number 4. So we want to change 34.95 to degrees, minutes, and seconds, and we're going to press enter. And it's 34 degrees, 57 minutes, 0 seconds. So you just write 34, 57 minutes, and 0 seconds, like that. So this next one is negative 72.775. So type in the angle first. Press second angle, or second apps. Press number 4. It looks like that. And it's negative 72 degrees, 46 minutes, and 30 seconds. Now, what if it's in degrees, minutes, seconds, and we want to change it to nearest thousands? That's 3 decimal places. This is 3 decimal places. That's what thousands is. Okay, so if we're going to do that, type all this in. It says right here, enter the angle as seen. Use degrees, minutes from the angle menu, and seconds is alpha plus. So we're going to type in, you're going to type in negative 128, and then you're going to press second apps 1. So let me clear this out. Negative 128. Second apps. Then see the degree right there, number 1? Press 1. That says negative 128 degrees. Now you're going to type in 30 second apps 2. So we're going to press 30 second apse, and now we want the minute symbol, which is number 2. And that says negative 128 and 30 minutes. That's what the first part is. Now seconds is not in that column. Seconds is somewhere else. So we're going to press 45 alpha plus. Because seconds is way down here with the plus sign. You guys see it down here? It's right above there. So you have to press alpha to get that. So you press alpha plus. Oops, I forgot to do the actual number. Do 45 alpha plus. And there's your 45 seconds, and just press equals. And it's negative 128, and they said nearest 1,000, so it's 513. Don't forget your degree. Don't forget your degree, because it's still in degrees. So let's try the next one. 29, second apse 1. 6, second apse 2. 6 alpha plus enter. That's what we're typing in. So it's 29, second apse 1, 6, second apse 2, 6 alpha plus equals 29.10, let's see, 0.107. So 29.10, sorry, 2, because the 6 rounds the 1 to a 2. Put decimal right there. All right, quadrantal angles. These angles are very important. They're always on an axis. They're always going to coincide with an axis. So, for example, this is 0. If I said draw 360, that's how you would draw 360. 0 and 360 are on an x-axis, positive x-axis. 90 is up here on the positive y-axis. 180 is right here. And 270 is all the way down here. So, you guys know any other ones? Basically, all the quadrantal angles are multiples of 9, 90s, 90, 180, 270. And then I'm going to line up 360 will be even with 0, 450 would be even with 90, 540 would be even with 180, 630 would be lined up at 270. You could keep going. These are all quadrantal angles that land on an axis. One thing that's good to know when you do your unit circle is that 1, 0, 0, 1, negative 1, 0, 0, negative 1 are the order pairs assigned to these quadrantals. So for example, all order pairs are in the form of cosine sine, if you remember this from last year, cosine sine. So if I said, for example, what is the sine of 270? 270 is right here. Do you see that? So if you look at the order pair that's assigned to it, it's 0, negative 1. And sine is the y-coordinate, so it should be negative 1. Your answer should be negative 1. You can also do that on your calculator by pressing sine 270, as long as you're in degrees. And there it is, negative 1. So we'll be doing that soon on the graphing calculator, but not yet. The unit circle's coming. So page 1 is done. Let me turn this over. Page 2, when it says, give me an angle that represents 9.5 rotations clockwise. 9.5 rotations clockwise means you're going negative. If you wanted to draw it, you don't have to draw it, but if you wanted to draw it, that's 1 rotation. 2, 3, 4, 5, 6, 7, 8, 9. Now it says 9.5. That's 9 rotations. A half a rotation is right there. This is where you would end up. Okay? That's how you would draw it. But what is that angle? So 9.5. So you are either going to multiply by 360 or negative 360, depending on the word clockwise or counterclockwise. Clockwise means negative 360. So your answer is whatever 9.5 times negative 360 is. So it's negative 3,420 degrees. That's what this angle is right here. But that angle is obviously too big, and I'll show you here when I go to coterminals, show you a way to get this to be a much more reasonable answer. Like for example, this is 180. I can show you how you can get 180 from that using coterminal angles. Actually, let's just do it right now, since this is already on our calculator. if I added 360, it's a little bit easier. If I keep adding 360, I could do this probably 10 times because we just went 9.5 times, right? You just keep adding 360 to get an angle that's more manageable, so you know where it lands. It's getting better. And one more. That's 180 degrees. So if I said, where does this land, this negative 3, 420, where does it land in this quadrant? You would say it lands on the negative x-axis because that's the same thing as 180 degrees. So negative 3,420 and 180 degrees are called coterminal angles. You can use either one of them to draw it. Okay, 6.75 counterclockwise. So we're going to multiply this by 360 because that's positive. Which is 2,430. That's your answer, 2,430. This is really light today. I don't know why this is so light. I'm going to give me a, oh, there, it's better. It's 2,430. Okay, if I wanted to draw this counterclockwise, this is 1, 2, 3, 4, 5. Here's 6. 6 3/4 is, that's 1/4, 2 quarters around, 3 quarters around. You would land here. So if I said, what's a coterminal angle that's the same as 2,430, I would say 270, just by my drawing. But if you subtracted 360 from this over and over and over again, you would end up at 270. So that brings us to coterminals. Coterminals are two angles that have terminal sides that are the same. The way that you're going to do that is you're just going to add or subtract 360 over and over until you get an angle between 0 and 360. So when it says, give me a positive and a negative coterminal angle with 86, well, 86, I know right now that 86 is right here. It's 4 degrees shy of 90. It's in the first quadrant, correct? So every angle that you give me should be in the same first quadrant, 4 degrees shy of this axis. So the positive angle would be 86 plus 360, which if you punch that in your calculator, you get 446. And the negative angle, oops, is negative 360, which is negative 274. 446 and negative 274. Now, if I was going to draw 446, this is what I would be doing. There's 360, and it's about another 86. So guess where it's at? First quadrant, same spot as this one. They land both in the first quadrant. If I said to draw negative 274, I'd go around. Here's negative 270 and another 4. Guess where we're at? First quadrant. So coterminal means they're in the same quadrant, same spot. They just look a little different. So you can use any one of these to draw this. So where's 294 at? 294 is, here's 270. So it's in the fourth quadrant, about right there. So can you give me two other angles that would be in that spot? So one of them you would add 360, and in one of them you would subtract 360. And just do that on your calculator. So the positive one is 654. And the negative one is negative 66. Okay, example 5. If each angle is in standard position, determine the coterminal angle that is between 0 and 360. So the reason you even use coterminal angles is because 595 might just be a little too large. Like, do you know what quadrant that is in just looking at it? You could try drawing it, but you might get it wrong. So before you even try drawing it, maybe work with the coterminal stuff, which is either add or subtract 360. Since it's bigger than 360, I'm going to subtract 360. So you do 595 minus 360, 235. And that is the angle that you want to be between 0 and 360. It says right here, it has to be between 0 and 360. 235 is between 0 and 360. Now, what quadrant is that in? 235, that's 180. You're in the third quadrant. So both those are your answer. Now, negative 77 is too small. This is too small. So maybe we can add 360 a couple times to get a more manageable answer that's easier to draw and easier to tell me what quadrant. So if you add 360, you still are in the negatives. So let's add 360 again. Now I like that angle. I know that's in the fourth quadrant. However, it says that it has to be left between 0 and 360. So I'm going to add 360 one more time. And that's 303. And the answer is going to be 303. That's the answer you want between 0 and 360. And that is in the fourth quadrant. Because here's 270, so it's like another 33. You're in the fourth quadrant. Reference angles are cute little angles. It says right here, it's an acute angle. It's between 0 and 90. The symbol for alpha, or for reference, is an alpha symbol. It's a Greek letter for A. And it's going to be between 0 and 90 because it's acute. Acute angles are between 0 and 90. It's always squeezed between the terminal side of an angle and the closest x-axis. I'm going to write the word closest x-axis. Always use the x-axis when finding reference angles. Use 180 or 360 to subtract or add. They're always going to be less than 90, and they're always going to be positive. They're always going to be positive. There's no general rule for finding it. You have to just kind of look at the angle and determine how far it is from the x-axis. Okay, so let's look at the next page. So example 6. Find the measure of the reference angle. So 312. Basically, the reason you use reference angles is because you have to use triangles in trigonometry. The word trigonometry has triangle in it. So you have to have angles that are easily used in a triangle. 312 is bigger than a triangle. The three angles of a triangle have to add up to 180. So 312 is too big of an angle to use a triangle. But there's another angle that is its reference angle that you can use the same as 312. So 312, we're going to draw it. Now, first of all, let me talk to you about closest x-axis rule. This, we're going to pretend like this is 270, okay? Going around the circle, 270, you know, like around Columbus. And we're going to pretend like you're just driving around and you run out, if you run out of gas here, the closest gas station will be on the closest x-axis. So you would walk back this way to get to the gas station. And you'd form a triangle here. If you were going around 270 and you ran out of gas here, the closest gas station is on the x-axis. So you would come down to it. If you had to draw a right triangle, it looks like this. If you were going around 270 and you ran out of gas here, you would go to the closest x-axis because that's where the gas is. And that would be your right triangle. And if you're going around 270 here, you go to the closest x-axis, which is right here, to form your 90 degree. So basically, there are two gas stations that are open after midnight. One's on the west side, one's on the east side. East side, west side. No north, no south gas stations. No north, no south gas stations. You always go to the closest x-axis. So here we go. We're going to start going around 270, 312 degrees, 90, 180, 270, and we have to go 312 is about another 42 degrees, so it's almost halfway right there. This is where you run out of gas. So the first thing you're going to do is draw in your hypotenuse. That's your hypotenuse. We're drawing a reference triangle. Then, this is where you're at, right here. You have to decide, should you go to this axis here, or should you go up here? Well, you need gas. There's only two gas stations open. One's on this axis, one's over here. So you're closer to this one. So you're going to go up to the closest x-axis. You're going to draw on a 90 degree angle. But this, right here, this is your reference angle. This is the answer. How do you find that? Well, since this axis is 360 and this is 312, you're going to take 360 minus 312. You get 48. That is your reference angle, 48. And that's what your reference angle is. So 48 and 312 are the same. So just type for fun. Type in cosine 312 and type in cosine of 48. They will be the same answer. Same. All right, negative 195. Sorry about the announcements, but I'm going to keep going. This is negative 180. Negative 195 is about right there. How many degrees did we just pass 180?
Good morning, Panthers. It's Tuesday.
Hopefully you said 15 because that is your answer to this. Your reference angle is 15. It's how many past the x-axis did you just go? So if I was drawing a reference triangle, there's my hypotenuse.
I'm Tyler.
This is you. You're going to go back to the closest x-axis, and you're going to take 195. I know it says negative, but you're just going to use the positive value of that, negative 195 minus 180, because you just passed the 180 axis. And it has to be a positive answer, so this would be 15 degrees right here, because you passed the x-axis by 15 degrees. 215. Draw it. Counterclockwise. There's 180.
Not completed ACC plus.
About another 35. Oh, I just said the answer because you had to draw about another 35 into this quadrant. So if you go up to the closest x-axis, this answer right here, you have to use the 180 for your subtraction or your adding. So you're going to take 215 minus 180 for a 35 degrees. That goes here.
Advertising and public relations.
It's like what? How much past the x-axis did you go? And 106.
Want to help make North the
That's
best
90. You're about right here.
Student council for next school year.
Now, even though it's closer to the y-axis, you never ever go to the y-axis. There's no gas there. So you're going to go to the closest x-axis.
Students who have not ordered and not picked up.
So this is 180, right? So what is this angle? This angle is 180 minus 106 for a 74 degrees.
The National Spanish Honor Society will be meeting on last Thursday of the month during E&I room
So
139.
complete the chart.
For more info,
Negative 320. We're going to sketch it.
And now today's Panther Sports.
That's 180. Negative 270.
What's good, all you
right
Panther Sports fans out there? It's Jake and Joe here with your Panther Sports.
So you're going to write this is negative 320 degrees.
4 o'clock, boys varsity tennis.
You should have an initial side and a terminal side. What quadrant it is in? That is first quadrant.
7 o'clock.
Give me one positive coterminal angle. So we're going to take the 320 that's given, and we're going to add 360.
And now back over to Tyler at the anchor desk with the
so this angle would have been a lot easier to draw if I just said 40.
Happy birthday
this
to
would be 40.
Panthers.
Negative coterminal angle.
Bowman, Benjamin Mason,
subtract 360.
Morgan Smonsky, Justin Clark, David Downs,
for negative 680.
And Adrian Amame.
And the reference angle is this angle, like right here. You go up here, go to the closest x-axis.
For the North News Network.
And even though it says negative, we're not going to use the negative. This angle is going to be 360 minus 320. So in this case, the reference angle is the same thing as the positive coterminal angle. That's not always the case. 160, draw it. There's 90, we're going to stop about right there. That's 160. Draw in your terminal side, right there. So this is 160. What quadrant is that in? It is in the second quadrant. Give me one positive coterminal angle with that. Add 360 to that. Get 520. Give me one negative one. Subtract 360. Get negative 200. And then give me the reference angle. Now remember, the reference angle is between 0 and 90, and it has to be positive. So basically the reference angle, you go back up to your picture. Go to the closest x-axis. We're trying to find this angle right here. This angle right here. That's your reference angle. If you're at 160, how many more degrees do you need to get to that x-axis? Hopefully you're saying 20, but the math of that is, since this x-axis is 180, you're going to take 180 minus 160 for 20 more degrees. It would take you 20 more degrees to get to that x-axis. 230. That's 180. So if you're in the third quadrant. A positive coterminal angle with that, you would add 360. That'd be 590. A negative coterminal angle with that is a negative 130. And the reference angle is, when you were drawing this, 230, and you got stopped at 180, how many more degrees did you have to go to get this? Whatever that is your answer, because this one, it is 230, and you always subtract with either 180 or 360. But since 180 is closer to this than 360, you would take 230 minus 180 for a 50 degrees. So there's a little, before I do the last one, there's a little reference chart for reference angles. If you land here, and I ask you for the reference angle, you're always going to take 360 minus whatever I give you. If you're over here, you're going to take 180 minus that. Anything here, you're going to take 180. I'm sorry, you're going to take theta minus 180. Like this is, let me think here. Yeah. And over here is, this one right here is 3. I'm messing you guys up. This one is 360 minus theta. This one is just theta, whatever it is. If it's reference angle. Try to use that SL chart. I know I just messed you up. So like, for example, the next one is 350. 350 is all the way over here. So you're in the 4th quadrant. So to do the reference angle, you're going to use this expression. So that means the reference angle is 360 minus the given angle, which is 350. So it's 10 degrees. Which you can't see because it's 10 degrees. So you take the 360, take 360 minus theta. Theta is 350. So you put the 350 right here. 360 minus 350 is 10 degrees. That's how many more degrees it would take to get to that closest x-axis. This is in the 4th quadrant. 350 plus 360 is what, 710. 350 minus 360 for the negative is negative 10. And the notes are done.